Good afternoon, everybody. Today I'm going to talk about openwips, a modular and open source WIPS. So on the agenda, I will first tell you what it is, then the origin of where the idea came from, and talk a little bit about the architecture of this thing, and then I'll talk about the internal design of things work internally, followed by the release plan, and then a demo. So first of all, I'm the author of Hyatt Regency and also work at NEK Advanced Security Groups. Openwips, we'll split the word to explain it. First, you got the first part, it's open source tools. W stands for wireless, and IPS is an intrusion prevention system. There are IDS and IPSs. IDS just detect intrusions and notify you of the intrusion. And IPS is react on these things, so they prevent the intrusion. The idea came from a project I started slightly more than a year ago, and didn't really have time to work on it lately. It was monitoring all the channels on 2.4 gigahertz. And I pushed the idea a bit further. Why just monitoring? Monitoring is not that interesting one. You can see lots of weird stuff happening on wireless networks. Then, by seeing all those weird stuff, why not detecting those weird things happening in IDS? And I pushed it a little bit further, and since these cards are pretty good at injection, why not do intrusion prevention system instead to prevent intrusions? This setup is based on 14 alpha. This was an early prototype based on a cardboard to see how much space I needed. So as you can see, a 19-inch rack will fit perfectly. So commercial IPS, wireless IPS, are freaking expensive. When you want a basic setup, you will need a central server to manage everything, and all the sensors that capture data, send it to the central server for analysis. The central server itself costs about 6 to 8 grand, and each sensor costs about $800 each. So for a basic setup, you look at 10 grand. This is really expensive. There is no existing open source solution yet. I saw Stealth Wireless, but it hasn't been updated in a while, and Snort doesn't have anything wireless built in, so the project hasn't been merged. It's almost dead. And I also wanted whips just to play with, but just spending 10 grand on something to play with, and just for a home network, it's quite a bit of waste of money. So I decided to write one myself.
I'll do a free trial.
Thanks. I accept it. Sorry?
You gotta go back.
So the architecture of this thing is basically the same as commercial one, separated in 3 different parts. The main one is the server, which is going to gather all the data, make the analysis, and react. Sensors, those are just dumb devices that capture traffic, send it to the server, and from time to time they need to inject data. And the last one is the interface, which is how you access the whips and how you access the system and manage it and get nice reports. So here the basic the architecture, and it is going to be modular. Most of its function, most of its detection and reaction functions will be in plugins. So on Windows you will look at DLL, on Linux you look at shared objects. Unfortunately, some checks need to be done before calling all the plugins, like basic frame check, etc. The advantages of this thing is that there is no need to recompile a server when you create a plugin, when you want to add a feature. If you have proprietary code you want to distribute in a plugin, it's the best thing to do. You can give the plugin already compiled. You don't have to worry about the license. And for developers, just a few functions to implement. Most plugins will run on the server because that's where all the CPU power, GPU, and FPGA power is. And also because that's where all the packets go. And that's where you got the whole picture. In some rare cases, you may see plugins on the sensors. Type of plugin, there will be frame analysis. That's the most common type of plugin. There are several layers in it. Logging, for example, if you want to not to log to openwips but to syslog or your custom logging system. The alerts will let you get alerted in case of intrusion. For example, an email, a text message, or anything else. Database connection, by default, will provide a SQLite database. But if you need MySQL, Oracle, Postgres, there will be plugins available for that. And the last one, which is a script wrapper, that lets you create quickly plugin using scripts like Ruby, Python, and can be any script, any type of script. Multiple sensors can be a nightmare because they see different picture, the different parts of the network. Sometimes they see the same parts, sometimes just some small part of it, and they always see the same traffic. So the servers will take care of reassembling the data, remove all the duplicate traffic, and then process it. That means calling plugins. The intrusion prevention, most of the time it will use the sensor we see the most of the attack. When attacked, in most cases what happens is that the attacker will get deauthenticated, and it's going to be logged, and the administrator is going to be alerted. In case legitimate users are attacked, both the attackers and the legitimate user are going to be banned until the issue is resolved. You don't want one of your users be part of the attack against your network. And it can also prevent your users to connect to other networks if you want. DOS, we can detect denial of service. It's not that hard. All you can do is wait for it to finish. Fortunately, if vendors say they can stop it, that's bullshit. Or you can make it stop. Unfortunately, software can't do much, but we have a hardware add-on that is capable of stopping it. It's cheap and widely available, and get the job really quick. So it's a baseball bat. And since it's really cheap, you can fill an expense sheet to get reimbursed for it. And that is called baseball bat restoration of service. It locates the attacker quickly and accurately. That's the guy who runs with or without a laptop when he sees you. It costs about 15 to 30 bucks on Amazon, and you can find it in different sizes. You can probably find one that fits in your backpack. Now let's get a little bit more serious. The internet design. This part is going to be a bit more technical. So you remember the architecture? You have the sensors, the server, and the interface. So the sensors are going to connect to the servers. There are two different channels, one with the commands and one with the remote pickup. And this thing is going to be encrypted. The interface, there will also be a command and a pickup channel, and also going to be encrypted. Database, most of the time it will sit on the server. It's a SQLite database, but it's available. You could use an external one. So communication between the sensor and the server, and as well as the server and the GUI, is similar to FTP. You have a command channel where the sensor authenticates to the server and establish the pickup link. So the data channel is going to be the remote pickup. What you'll see in that is binary data. And basically this is exactly the same as what you can find in a pickup file. And both channels are going to be encrypted by default. So here's how the command works between the sensor and server. First is going to send a version of the protocol, and the server is going to accept it or not. If it does not, the sensor is going to try to fall back to a previous version until it finds one. If it doesn't, then it's not going to connect. Then send the login passwords, and that's where we're going to verify the credentials. And ask for a configuration, and then that's where the server sends the remote pickup configuration, the port where it has to connect, etc. The plugins, as I said, there are a few different types, and a script wrapper that let you use a scripting language to quickly do the plugin for, and that works for any type of all those 4 types of plugin. So this is very easy to do a plugin. You just have to use any programming language that lets you create DLL or shared object. C, C++ can do. I'm pretty sure a lot of others can do. You just need to expose the functions. There are some common functions to implement for all kinds of plugins, like initialization, getting a type of plugin, getting the version supported, etc. And then the function specific to that plugin. You will receive all the wireframes, but you want to take care of keeping them. The server will take care of that. Then compile it, edit the configuration, and restart the server. The script wrapper can be used for any type of plugin, frame analysis. You can use it for using any scripting language. The same functions have to be implemented, and this thing is a plugin itself, but need a few parameters, and it needs at least the path to the script, and the language of the script. So we'll see here how a plugin is made. First, the function to implement, a small example, the make file, and then how to install it. So here's a basic plugin for frame analysis. You have a few functions there. These functions just need to be implemented for any kind of plugin. First one is going to initialize the plugin. You give it the config line. That means all the parameters going to receive, and it's going to receive as well the version of openwips. The second one frees all the memory. So when we're done with the plugin and exiting, we're going to call that function to make you free any data you would have initialized in this function. This one is going to return the plugin type if it's a frame analysis plugin, database connection, logging, or alert. The minimum supported version of openwips for that plugin and maximum supported, and an initialization text, something that we're going to log to show that the plugin has been loaded correctly. Then, in case this is a frame plugin, so you will have to implement those functions. These are saying if, for some optimization, if you need a specific type of frame or subtype. And the following one are going to be used for detecting the attack and getting the details of the attack. So in this case, this one is a very simple one. We're going to check a few bits to make sure they're correct. And since we need to keep some data, we're going to return a pointer to something, to our configuration. And as you can see, this is frame analysis plugin, and the minimum supported version is currently this one is 0.1. Only support that version, and this is what is going to be logged when the plugin is loaded. In this case, we don't care about any type of frame. We're going to analyze every single frame, and not only for our clients, but for everything else. So this function returns if this frame can be used. So as you can see, we need the frame to be different than data frame. This one says, is it possible that it's an attack? Or is it possible that it is going to be an attack? And then that's where the thread that is going to gather all the packets for this plugin is going to start recording those data and keep it for the plugin. And this thing can determine if we need a specific amount of frame before starting analyzing if it's an attack or not, or if it needs some time before it, or if it's a frame rate based attack, if you combine both. And then this one is going to return if if there is an attack or not. We're going to do some basic check. And the last one is give the details. In this case, this is anomaly on the network, because these bits need to be set only for data frames. So it's really not that hard to do a plugin. Compiling it. So let's see the make file first. There we go. This one. So just compiling and say it's for a shared object, and give it the name of the shared object. That's the actual name. That's it. So compiling it. So you're done. We just got 3 plugins compiled. And the configuration is quite easy to do. Those plugins don't have any parameters. So you specify here the plugin, the name of the plugin you want to reference, and the path to it. And if you need any parameters, you can add just right next to that. So here we have those 2 plugins enabled. And that's it. Packet reassembly, data can come from several different sources, and the devices, the sensors, see different parts of the communication, not always the same. Sometimes completely different, sometimes parts are the same. So we need to reassemble that. And how it works is that we gather all the packets from different sources, we put it into a list, we discard all the duplicates. Most of the time is very easy. And then sometimes we need some reordering because of the arrival time of some package. Now the release, the first version is going to be released in 2 weeks. How I see it is that it needs to be tested. I'm looking for testers beside me. And since we're going to have to rewrite, I want to do first a few versions of this thing, and from that experience rewrite it in C++, since we're going to see things changing. Version 0.2 is when we will have more modules, more features, and obviously bug fixes. 1.1, you will see the graphical user interface. Version 1.2, you will be able to locate attackers on the map thanks to the GUI. Usually you need more than one sensor to do that. You could do that with a single one, but it's not going to be very accurate. The more sensors you have to cover a place, the more accurate it's going to be. And 1.3 it will be available as a module for OpenWRT or NPFSense, if it hasn't been done before, etc. What you can expect is 0.1 is having a sensor, and the server supports a single sensor. supports more than one connection, but the behavior is not the behavior is unexpected because we don't do any reassembly. Plugins available: frame analysis and logging. We're going to be able to detect all the attacks of Hyatt Regency and a few other attacks available, and logging, and probably alert plugin, as well as documentation for getting it, compiling, setting it up, and using it, and also documentation for creating your own plugins. 0.2, you will see encrypted communication between the sensor and server, as well as channel hopping. The server will support multiple sensors, more plugin types, and more existing plugin types, and bug fixes, obviously. 0.3 we'll see a real remote pickup. For those who don't know, Wireshark supports remote pickup, so you can connect to a remote server to do packet capture. Unfortunately, that tool only exists on Windows. You can find it in a Wireshark folder. It's a rpcap.exe. And basically, you connect to an address rpcap // the address of the server. And we're going to support the real one. So, and hopefully contribute to do one for any kind of interface. Server, you will see database. We need to see what is worth storing in the database. We need to design it. And there will be more plugins and script wrapper plugin. There will probably be 0.4 to fix bugs in that version. 1.0 will be based on your inputs and the experience we had with it, things that need to be changed, etc. For a development point of view, C++ is much easier, and it's not slower than C. And there won't be any change on how plugin works. There might be a few more functions and maybe more plugin types. And for a following version, a detailed planning will be available on the website. You probably want to see how this thing works. And I first wanted to do a video, but unfortunately I left all my video equipment at home. I didn't have time to do one, so let's see it in action. So here I just started a server. It parsed all this configuration and then started loading the plugins. This is the one I showed you earlier, and it doesn't have any parameters. This is a debug mode, so we see a lot of information. Loaded the functions correctly, and give some details about the settings of that plugin. And this is the line that is returned by the function. The following one is that you're going to see is the authentication attack. This plugin detects the authentication. And it has, as you can see, it requires some specific frames, so only frames type 0, which are management frames, and subtype 12, which is the authentication frames. So as you can see, it successfully read this configuration. Started the packet reassembly thread. There's nothing yet, and packet analysis, which is where it's going to gather all the data for the plugins and call the plugin. And it is waiting for sensors. So I'm going to start a sensor here, specifying the monitor interface, the address to the server, login and password. You can see the whole communication between the sensor server. It sees that it's connected to the remote pick app, accurately feeding a server with all the frames. Now I'm going to do the authentication. First, broadcast the authentication. No, I'm not targeting any access point here. It's just an existing MAC. But you will see the detection here. So, as you can see, it just detected the authentication. It's broadcast the authentication. Since this thing should never happen on networks, you should never see broadcast the authentication. As soon as we see one, we're going to detect it and warn. You might wonder why there are so many alerts. I'm going to throttle that and show only one. But when you start a replay in that mode, it is not set. When you set to send a 1, in reality it sends more than just 1. So as you can see, it sends not 1, but a bunch of them. Like 256, so quite a lot. And we're able to detect a replay since it has a specific signature. And then it's able also to detect the regular the authentication. Your access point sending the authentication will not trigger that thing, since it needs a specific amount of frames before triggering. Yeah, the replay sends the authentication packets in both directions, both to the client and saying I'm the access point, and to the access point saying I'm the client, I'm the authenticating. So there we go. So the first version is going to be released in about 2-3 weeks. The code's in some polishing and more testing. Tester will be conducting about a week. There will be a week for testing. And we're going to have to write the documentation, and there will be a bug tracker and a subversion repository available. The website is already up with some basic information. And IOC channel is available on Freenode. It's openwips.ng. We need coders and testers, so contact me if you're interested, or even if you have ideas, remarks, or any suggestion of things that can be added to this software. That's all. Thanks, everybody. Do you have any question? Yeah.
Does the idea of all the sensors sending the traffic to centralized servers, is that going to scale? That be 5 sensors or 10 sensors or 20 sensors?
Depending on the business of your network, there will be a few options available on the sensor. You will be able to do some processing on the sensor if you don't want to send all the traffic through your network. I'm going to find how I can make the sensor do the processing and make the plugins do all the processing on the sensor and be compatible with sensor. Another option you can do is discarding all the payload from the data frames. So that would be the most common frames you can see on a wireless network. You will be able to tell the sensor to not send the content of the data frames. Yes.
What chipsets are you going to support? Are you going to be looking at wireless, branch, or anything specifically for coverage, like the authentication, or just the sensor portion that's not going to be supported? Just you doing it.
The question is, what are the chipsets supported? All the wireless carriers supports monitor modes and are capable of injection, can be used with this software. Yep. And even on Windows, we will support the AirPickup device. So if you want to run a sensor on Windows, that will be doable. Any other? Yeah.
Yeah, our PCAP protocol I've seen only supported Windows version of Wireshark. You know, there's plenty of supporting Linux.
It's about the remote pickup protocol. The protocol, I think you can do a remote pickup, connect to remote pickup from Linux, but you can only start it, create it on a Windows machine. The tool is only available on Windows. And what I'm going to do is make a tool available on Linux too. So we can support wireless and even any kind of interface. Yeah.
How are you talking out the bad? If you're like, okay, you got one bad user in your packet, whatever. So how are you black opening together?
Is it about legitimate users that are attacked?
So basically a bad user, yes, attacking.
So when we're going to detect an attack, if we can de-authenticate the user, and we're going to prevent him from joining the network. So we don't want that user to be part of the attack, or if he's not the origin of the attack, we don't want him to help the attackers joining the network. So we're going to ban both from the network. But that will be configurable. And you will have to solve the issue and tell the whips, I'm allowing that user again. Any other question?
Are you going to provide a mechanism so that once layer 2 IPS rules are passed, that I can sort of pass to layer 3 to go back to station 1 or another type of IPS or IPS?
Yeah, I was thinking about that. The frame analysis plugin, there will be several layers. First, there will be the basic one. We can work with the frame that comes directly from the air. There will be another layer which is will be decrypting the traffic in case it's web or WPA, and that's where the GPU is going to be handy when you have a busy network. And then you can add another layer in case you have a VPN to decrypt the traffic. And at the end, you will see the traffic unencrypted, and you will be able to send it to something else. Any other question? Thank you very much.